Okay, so first talk about benefits of pulses in crop rotations. One of the oops, my screen seems to get wonky here once in a while. So water and nutrient use efficiency in crop rotations. This is important, and so I'll start off with that. It's about average rooting depths of our common crops. So pea and lentil go not too deep, about 2 feet deep, and they're fairly shallow, the roots, and they're thick. Canola are about 1.5 meters or 4.5 feet deep, and wheat are 1.8 meters or 4 to 6 feet. So when you're looking at pulses of about 2 feet, canola with 4.5 feet, and wheat with 4 to 6 feet, you're looking at, when you have these crops in rotation, you're extracting soil water and soil nutrients from different depths of the soil profile every year. You can see how that's beneficial for soil water and nutrient use efficiency. Pulses are well known, all legumes, for nitrogen fixation. Pulses are legumes, and they grow with beneficial soil bacteria called rhizobia. I'm sure many of you are aware of this, and it's not anything too new, but I'll just review it here a little bit. We inoculate the seed of our pulse crops with a pea, lentil, or other pulse with the proper rhizobia strains. So they're specific. Rhizobia are species specific, so you need to use the correct rhizobia strain. Many manufacturers have mixed strains now. You can buy single strain, or you can buy the mixed strain that has rhizobia for various pulses all in one bag. So we do this liquid-based, peat-based, or granular. Granular, the research shows that granular is a bit more effective, but not terribly much. So peat-based and liquid-based are also fine. Rhizobia, they create a nodule formation on the pulse crop roots, and you can see at the bottom of those pictures, those little they're little factories of nitrogen. So these rhizobia, they convert atmospheric nitrogen, which is in the soil airspace, into plant available nitrogen. And our pulses fix up to 80% of the crop's nitrogen needs, and this is often over 100. Most of our pulses can fix over 100 pounds an acre if weather conditions are good and soil roots are healthy. Amount fixed, just a brief overview of amount of nitrogen fixed by various pulse crops. Faba bean is a big winner. It's 80 to 160 pounds per acre. Field pea, 50 to 150 pounds. Lentil, a little bit less, 30 to 120. Chickpea, a touch less. Oops, I got space. Something's showing up here again. I got to get rid of it. Okay, sorry. Chickpea, 20 to 100 pounds. And dry bean is the lowest, 50 to 70, but it still does fix some. So the lower level would be that the plant's not in great shape, or you're having a drought year or something. The high is under good conditions. So nitrogen fixation doesn't begin right away. It begins 3 weeks after seed germination, and it occurs up to flowering stage of pea and lentil, and it stops at seed formation stage of pea and lentil. However, with faba bean, faba bean fixes nitrogen right up to physiological maturity, so right up to harvest time. That's why you see more end fixation with faba than the other pulses. Factors that affect nitrogen fixation effectiveness: overall crop health, drought or cold weather, poor root system. If the low soil nitrogen is important. If you have too much nitrogen in the soil, the end fixation system won't work. The rhizobia get a little bit lazy if there's already nitrogen there. Now, the end fixation system also requires phosphorus. So this is why I always suggest add ammonium phosphate to your as a fertilizer. Most of our pulses do not require nitrogen as fertilizer, but because they fix so much of their own nitrogen, and there's also a little bit in the soil that they extract. But it's important to add some phosphorus fertilizer, because phosphorus is important for the nitrogen fixation process. Phosphorus is good for overall root health. Phosphorus also helps with weed competition, and it causes earlier maturity of your crop. So phosphorus is important, not just for the end fixation process. Now, an indication of nitrogen fixation effectiveness is the red inside the nodule. So it's not a matter of how big these guys are when you dig down in the summer and look at them. It's a matter of how red they are. So the one in the middle, the one on the right's not bad. The picture in the middle is perfect. And you see a lot with on the left too, and it's got red, so it's doing okay. Now we often wonder how much nitrogen is remaining in the field for the next crop, and this is something we didn't realize, couldn't figure out in the 90s. We knew there was something happening there for the next crops, but it wasn't until the 2000s that there have been two experiments done, one in Lethbridge, one at University of Saskatchewan, and we know that 70% of the pulse's nitrogen production is removed with this pulse seeds. And so that the research is saying that available soil nitrogen for the next crop is 3/4 of a pound of nitrogen per acre of every bushel to the acre harvested. So that would be 40 bushel pea crop would be 30 pounds of nitrogen for the next crop. So that's a nice ballpark figure that the researchers have supplied for us. This, of course, is an average field that's, it hasn't been hit with hail or something like that to reduce its yield, but this is just a general statement, and it's good to know that. Pulse has also increased the value of wheat grown in rotation. So if you grow wheat after pulses, there's a slow release of residual soil nitrogen from the pulse crop throughout the next growing season, which helps promote high protein wheat. And of course, we know we can get a premium if we've got high protein wheat. So brings in a little bit extra money. Pulses help out that way. And just as a note, synthetic nitrogen fertilizer is only available to the crop for 4 to 6 weeks at the beginning of the growing season. So pulses give a nice flush of nitrogen throughout the growing season. I do know many pulse growers that prefer to grow canola after a pulse like pea and lentil because they see a nice progression of improvement of that crop over the growing season with the additional flush of nitrogen. So some growers prefer canola, some growers prefer wheat. Pulses promote beneficial soil microorganisms. Now I'm going to talk about AM fungi here. I started working with pulses in the early 1990s with Dr. Slinkard at the University of Saskatchewan, and I worked with the Saskatchewan pulse growers managing their applied research program. So Dr. Slinkard was just a great, he was the one that brought pulses to Canada in the 70s. And so it was great to have him as a mentor. And he always said, there are rotational effects. We don't understand what's happening, but there are positive rotational effects happening after we grow pea lentil. And so it wasn't until later that sometime in the 1990s, early 2000s, they started defining what some of this was, microbiologists. So main one is that arbuscular mycorrhizae fungi, I'll call it AM fungi. They colonize with the pulse legume roots. And of course, we are now knowing through, Karen has a lot of knowledge on this about other soil microbiota, not just AM fungi, but there's a lot of positive little animals in the soil doing great things for our soil and our crops. But we'll just touch on AM fungi here. AM creates a vast network of thread-like microscopic channels between the plant roots and the soil. So 1 gram of topsoil can contain up to 100 meters of AM microscopic threads. AM fungi penetrates the soil beyond the reach of the roots, increasing uptake of nutrients and soil water. So these are the rotational effects Dr. Slinkard was talking about, part of the rotational effects. There are other positives as well. A little bit more about AM fungi. AM fungi enhance nutrient uptake, not just the reach from the roots that they have, but they also especially activate plant available phosphorus, which is extremely important because phosphorus, as you know, is an immobile nutrient. So if this fungi helps to break down rock phosphate somehow, and the AM promotes the crop's greater access to soil phosphorus. So big benefit there. Drought tolerance, of course, it's when you have a little more rooting system through AM fungi, it's beneficial to extract more water during droughts. Increased disease resistance. They help prevent disease. So there's a bit of biocontrol there. Soil quality, this is so huge. I mean, the AM fungi, soil microbiology, it creates sticky strings that hold the soil particles together. And this helps not just with the pulse, with your overall crop rotation. All your crops have better root penetration, better soil aeration, water infiltration, and of course prevents erosion because it helps stick the particles together. AM fungi stimulate the growth of decomposing microorganisms, so it helps break down residue, which improves nitrogen release. Crop rotation increases AM fungi. So 80% of plants associate with AM fungi, including cereals and pulses. Pulses have an especially strong relationship with AM fungi, researchers found out. Now, Dr. Cynthia Grant and others at the University of Manitoba found out that oilseeds do not associate well with AM fungi. So if you do have canola, mustard in your crop rotation, you really do need to have pulses in there to keep that soil healthy. So crop diversification that includes legumes promotes more AM fungi. Pulses break disease cycles in other crops. This is natural. You have a lot of our diseases are species specific. So they're specific to each type of crop. So you got that which affects oilseed, generally doesn't affect cereals, which generally doesn't affect pulse crops. But you do have some that affect all of them. For example, sclerotinia. Sclerotinia is common in most broadleaf crops. But if you do have a pulse in there, you do help to break the disease of in cereals like cereal leaf diseases, fusarium head blight, ergot, oilseeds, break diseases of clubroot, blackleg. But as I said, sclerotinia would not be there. The sclerotia sit in the soil for about 5 years. And also the spores from sclerotinia can blow in from outside the field. So just like with diseases, pulses help break the insect cycles of other crops. So not all insects. So something like grasshopper pretty much eats anything. However, cereals, wheat midge, and sawfly, oil seeds, root maggot pulses will help to break those cycles of insects. You can earn more money by growing pulses. You just use less synthetic fertilizer overall, which is a savings in money because these fix for their own fixed nitrogen for their own well-being and for the well-being of crops afterwards, which we discussed. Diverse crop rotations use less pesticides. So the main one is fungicides because you're going to have less disease, which we just discussed. Niche market or main commodity. This is interesting because some growers will learn how to grow something like lentil, which has a bit of a learning curve to it, and just grow it when the price is high and make some good money. Many growers, pulse growers, have pulses, pea, lentil, perhaps fava bean in their rotation as a main commodity, especially pea and lentil. Longtime pulse growers always grow pulses regardless of commodity price to achieve the positive rotational effects, including enhanced soil quality with AM fungi, which saves money in the long run by creating healthier soil. Can't say enough about that. It's really important. Pulses will earn you more money from now going forward because of value-added processing. Value-added helps us grow, helps us penetrate additional markets. Just elaborate on that a little more. It's this is a new phenomenon on the Canadian prairies, but we've got these plants that have started up, and they're going to be nothing but good things for pulse growers in the going forward. So pulse processing is adding value, provides economic opportunities. For pulse crop producers. So we got splitting facilities on the prairies now. So we used to sell, and we still do sell a lot of our pulses whole seed, but now we can split them and sell them more at a premium. Fractionation plants are happening on the prairies. Fractionation separates seeds into fiber, starch, and protein fractions. So, for example, you can create plant-based protein for human food. You can add protein to pet food, to livestock and aquaculture feed. In the case of human food, you can add like a pea-based protein. You can add it to products like noodles, biscuits, snack food, breakfast cereal, etc., giving them more protein. This is interesting too. The cosmetics industry, there'd be healthier cosmetics for people, women who wear cosmetics, if it's made from pulses, like from peas. Bioplastics, medical supply industry, that's a really interesting. You walk into the doctor's office and you see all those plastic instruments and everything around. They're going to make those out of pulses in the near future. So there's research going on right here on the Canadian prairies, making converting plastic products into at least part of it would be pulse made, so it would be more biodegradable. Good things happening. Pulse crops. These are the acres grown on the Canadian prairies. This is a 5-year average. So Saskatchewan has 6.7 million acres of pulses. Manitoba and Alberta have 1.8 to 2 million acres. Saskatchewan, of course, has a larger area for agriculture, so it's natural they would have more. In the next, I'm going to talk about what's in Alberta here. So in Alberta, we have soybean, we have 10 to 15,000 acres, chickpea 35,000, dry bean 55,000, faba bean 40,000 acres, lentil 450, so closing in on 500,000. Pea is 1.7 million. Some years we have 2 million acres. And lupin is a new crop for us, and it's being researched right now, and it's got a future. It's not growing much at all, but it's got a future in the processing world. So we'll talk about lupin here right off. Lupin, blue and white. I really don't know a lot about lupin. It's a new crop. I do remember it on Dr. Slinker's plots back in the early 90s, but that's the only experience I've had with it. People like Robin Boness are working on lupin, researcher at Lacombe. There's no commercial seed available yet. They're currently researching agronomics. I just talked to Robin a week ago. They're looking at seed rates, seed dates, herbicides, but it's got high protein. That's why it's good for for food processing, or for processing and fractionation. It's got 35 to 40% protein content. Pea, for example, is 24%, and it yields pretty well, 30 to 45 bushels to the acre. Its utilization, as I said, was for processing, and it's a fairly long season maturity crop. It's 110, 125 days. It prefers cool, wet weather. So you folks are right in the right area in the black soil zone for this crop when we able to use it. I inquired about whether it could be used as a green manure plow down, and they said no, it's a woody stem, so it's not good for manure plow down. Soybean, we'll turn to that. Soybean, not much grown in Alberta or Saskatchewan, requires warm growing season throughout the entire growth cycle. Daytime temperatures above 20 degrees Celsius for optimal flower and seed formation. It's a fairly long growing season, 112 to 125 days to maturity. So you can see all these things. You can see why it's so popular in the States, because it really fits with their climate. Seedling, and southern Ontario too, of course. Seedling is susceptible to spring frost. It's got epigeal germination. The cotyledons are actually pushed above the soil surface. I'll talk more about that later. And Alberta acreage is very small. Manitoba has the most acres of soybean on the Canadian prairies. Chickpea is an interesting crop. You know, it's something that's only grown in the brown soil zone in the driest regions of the Canadian prairies, but it has a lot of potential. And I think we can start growing it here fairly soon. I'll talk about that a little later. Now we've got the Desi and the Kabuli. So the Desi is a bit of a shorter growing season. And if you look at the top right-hand corner of my slide, I've enlarged these seeds. The dark one on the left is the Desi, and the larger one on the right is the Kabuli. Now the Kabuli is used in salad bars. You'll find you in salad bars in the city, whatever. Maybe put it in your own salad. I don't know, but it's used in salad bars. That's its use. The one on the left, Desi, it is smaller. It's got a more pronounced beak on it. That's why it's called chickpea. And it is split. And people in India use it to, in the Middle East, use it to make dal, D-A-H-L. So we can grow this stuff pretty well. The beak is a little bit of a problem in our air seeders. If you break it off, it damages germination. But I'll talk a little more about that later. But the main problem with chickpea is its ascochyta blight. Now, ascochyta blight in pea, lentil, chickpea, it's a different type of ascochyta blight. They don't, we do call them ascochyta blight, but they don't. One from chickpea, for example, does not affect the lentil or pea, so they're specific. But it's a very serious plant disease in chickpea. Even in the brown soil zone, you can see that picture I'll have on the right of those tram lines. They've been spraying. They have to spray this chickpea something like 3 times. I've seen it 3 times during the growing season. That's in the dry zone of the prairies. So repeated fungicide applications in one season. So it's confined to the drier soil zone. It's actually really easy to harvest. It doesn't grow far from the ground, but the pods, seeds are all up in the air. You can actually zip along really well and harvest this crop quite easily. So the research is going on for disease resistance, shorter date, less maturity length, and more rounded seed. So we don't harm that beak. This is interesting work that Lana Shaw, research scientist at Indian Head, Saskatchewan, is doing. This is intercropping chickpea with flax. So if you look at the picture on the right, you see the tall, lighter plants. Those are flax. The lower ones in between are the chickpea, darker. And so they're intercropping this. And what they're finding is that it prevents some of the challenges that I was just talking about. So the flax actually stresses the chickpea. So you get 7 to 10 days earlier maturity, which prevents fall frost damage to the chickpea. You get disease reduction. The flax actually prevents ascochyta spore transfer. So the spores cannot transfer all through the field. And so you may get a little bit of disease, but it's not ever at epidemic proportions. And apparently they've never had to spray for disease. So that means we can grow chickpea in wetter soil zones. So if Battle River Research isn't already growing this as an intercrop, it would be a good idea to maybe start, because Indian Head is the same soil zone as we're Battle River Research Group. So it might be an interesting research. Maybe Battle River is already doing it. But also as herbicides, Authority herbicide is registered for both chickpea and flax. You can get pretty good weed control. And the chickpea, interestingly enough, helps thresh the flax bolls like small ball bearings when you're combining. So what you do is you target the monoculture plant density of chickpea. So you plant your regular rate of seed for chickpea, which is 4 plants per square foot, and you reduce the normal flax rate down to 1/3. That's what the research is telling us. Interesting. Dry bean, it's a challenge for us in Alberta on all the prairies. It requires a warmer growing season, ideal daytime temperature, 20 to 32 degrees Celsius. It's a longer growing season. It's 115 days maturity. It's very sensitive to spring frost. So seeding, they actually have to wait until May 25th to June 5th to plant this crop. It's got epigeal germination, which is the same as a soybean. So the cotyledons, the food source, is pushed above the soil surface. So you can see the diagram just at the bottom there. I'll try and use where is the arrow? Anyways, it's the arrow? Doesn't matter. Okay, in the diagram in the middle at the bottom, epigeel is the second from the right. So you can see the seed, the cotyledon, which holds the food inside the seed, it goes above the soil surface as it's germinating. And so if that gets nipped by frost, the whole plant dies. Whereas pea and lentil and faba bean have this hypogeal germination. So you can see that brown seed stays below the soil surface, and it pushes the plant, the seedling upwards, and the food source stays below the soil surface. So if you get frost, early frost is not going to damage the crop. It'll come back again because it's got the seed source. So you see on the right, beans in your garden, you know how they kind of curve up from the bottom, and the inside of the seed shows up above the soil surface. So that's very problematic. That's why we can't. That's why it's so vulnerable to early spring frost. These beans are mostly grown in the Bull Island and the foremost areas. And as I indicated before, we don't have a lot of acres of dry bean. Faba bean, though, grows well. We know we can grow it. And I know people in your area, some people listening here may have grown it. So it's successful faba bean production in wetter zones, mostly black, gray soil zones in Alberta and south in the irrigation area. Challenges: it's got market development. The market development isn't refined yet, and agronomy researchers are working on smaller seed size because the seed is fairly big with most varieties and can be a bit of a problem in the air seeder. And of course, we're working on earlier maturity. There's a fall frost risk. It's a long growing season, 110, 130 days. So if you seed, you should seed by May 8th if you can. Like I was saying before, it can handle some spring frosts. They say if it's May 15th or later, you may want to change crops because you're going to get nipped with frost in the fall by seeding that late. Its use is for human food consumption in the Middle East, livestock feed, processing, fractionation, and it's a really good green manure crop. A lot of organic growers grow faba bean as a green manure. Research is going for a shorter growing season and a smaller seed. So I actually put the pros and cons of faba here on the left. The pros: high nitrogen fixation, 30% protein in the seed, human livestock feed, silage, and green manure, standability, very easy to harvest, 30 to 40 bushels to the acre, but I know some of you out there have gotten 50 bushels to the acre, maybe more even. The cons and negative, unfortunate, the challenges are that it's long growing season. Researchers are working on that. Rainfall requirement is about 15 inches. I've seen it growing on 8 inches, but that's under ideal conditions or timely rainfall, I should say. And so it's good in the thick black soil zone where you do generally get 15 inches of rain a year. It's got a large seed. Some of the varieties are large seeded, so it can plug the air seeder. But the problem is, if we make the seed too small, the consumer in the Middle East and India doesn't like it. Consumer choice is interesting. They choose the larger seed. Lygus bug is problematic. causes a black spot on they bite. I'll talk about that a little more. They bite the unripe seed, and it reduces quality. Market is still questionable. Faba bean types grown in Alberta. We got snowbird, which has been the most common over the years. It's a large seed, fairly large. It's got low tannin, and it's used as human consumption and livestock feed. So if you grow it, get frozen in the fall, you can sell it into the livestock feed market. And Malik is a larger seed. So it does have some air seeder problems, but there are growers that do grow it. It's got a tannin in it. That's what makes it a darker looking seed. And the flower has a black spot on it. And the snowbird doesn't. Those pictures on the right there. So it's got tannin, and it's for human consumption. Humans like to eat the tannin. They like the little bit of a bitter taste, but it's not palatable for livestock. Livestock don't like it. So if you grow this one frozen in the fall, you're kind of hooped, because you can't seed it you can't sell it for human consumption or for livestock. Maybe some of you have some more experience that you could enlighten me on about this after I talk. So there's a new one, Fabal, is a newer variety. It's medium-sized seed, slightly larger than snowbird, but smaller than Malik. It's got tannin, so it's human consumption, and it'd be used for fractionation. And it's got a medium maturity. It's about 120 days. Now, this is interesting. Plant breeding is trying to get a smaller seed, smaller and rounder seed. So for easier seeding, not plug the air seeder. And so these ones, Snowdrop is the one that they've come out with. It looks like a pea, actually. It's small, and it's got zero tannin, so it's only for livestock feed. As I said before, insect pests are pretty serious. Lygus bug enters from canola fields, and they suck the developing seeds, and you get downgraded. And actually, they say insecticide, it doesn't work that well, because you spray it and they'll just come flowing in from the nearby canola fields again. Pea leaf weevil is the most fairly serious insect issue with faba bean now. 2008, we found out about pea leaf weevil in the southern part of the province, but now it's traveled all the way up to the north. They eat the nodules, and it affects nitrogen fixation. So what they do is they come out of where they spend the winter on the field edges. They come out into these crops in the spring and chew on the leaves, and they go down into the roots, or they lay eggs, and the larva or worm hatches, and they eat the nodules. So you lose all that benefit from the end fixation. Symptom, of course, is the leaf notching, and seed treatment is more effective than foliar or post-emergent insecticide with pea leaf weevil. Dry pea, we got field pea. It's our most common crop. It's used as human consumption, including fractionation, and for livestock feed. Its protein content is 24%. We have green and yellow market classes. It's grown right across everywhere in Alberta as field pea. The main markets are India, China, Bangladesh, and of course, it'll be used a lot for processing in Canada. You can seed early. This has got the high pidgeal germination. Its cotyledons, or food source, stays below the soil surface. And so early seeding is okay. It can tolerate 1 or 2 spring frosts down to -4 or -6 degrees Celsius. So look at the diagram on the lower right-hand side. You can see the seedling, the largest seedling there. You can see at the soil surface, there's a node, a growing point, and just below that, there's another growing point. So those 2 growing points there, if that seedling gets frozen off, it'll come back from one of those 2 nodes. So I haven't seen pea, but I've seen lentil come back twice from a frost. Land rolling is important for peas as it is for lentil. Pushes rocks into the soil, dirt lumps, breaks up dirt lumps and smooths out soil ridges and prevents combine cut-a-bar and internal combine damage, prevents earth tag and allows faster harvesting speed. Rolling is standard procedure now with pea and lentil. You can roll right after seeding, or you can go 3 to 5 node stage, up to the 3 to 5 node stage. Grower producers have found out that when lentil and pea are just coming through the soil surface, just emerging, rolling can actually be detrimental. So if they're just coming through the soil surface, you may want to wait a few days. It's better to roll later in the morning because of turgor pressure in these little seedlings. The seedlings, they're full of water in the morning, which they collect during the night, and they're all stiff. So if you roll first thing in the morning, they're going to get some breakage there. So it's better to wait to about 11 in the morning when the plants are more pliable to roll. Field pea foliar diseases, ascochyta blight or mycosphaera. This is still problematic. We haven't been able to get on top of it with the plant breeding. So, but they encourage us to spray only if necessary because we can't overuse fungicides. We're getting resistance from diseases. So we don't want to lose this management tool. Spray the fungicide at the beginning of flowering or the onset of disease. And when I worked at the government of Alberta as a crop specialist, one of my main questions with peas was always diseases. When should I spray? When should I spray? So this scorecard takes a lot of guesswork out of it. So use a disease risk assessment scorecard for scouting. It establishes an economic threshold and it removes the guesswork. So here's the scorecard. If you have trouble finding one online or you want one, just call me, email me, and I'll definitely get one to you. It takes the guesswork out. So you look at crop canopy and you estimate the risk scale. Is it heavy or is it light? If it's heavy, you put down a higher score. Leaf wetness at noon, percentage of plants showing symptoms, 5-day weather forecast. And if this adds up to 65 or more, you spray. If it's less than 65, you don't spray. So it takes the guesswork out. It's a really handy tool. But sclerotinia is problematic as well. And you want to look at field history. If you've had canola, lentil, or sunflower in there, you will probably have more sclerotinia if you had sclerotinia in those original crops. Monitor the weather conditions and the crop density. So it'll only happen if there's real dense foliage. And of course, breeding has helped because the semi-leafless varieties, there's just less canopy, and so the wind can get through there a little bit more. And so that's been helpful. It emerges later in the growing season under warm and moist weather conditions and heavy dense canopy where there's less air movement. So scout and assess. You have to actually spray the fungicide before you see any symptoms. I know you're all familiar with this with canola as well. So apply a fungicide at early flowering stage just prior to canopy closure. If once the canopy closes, you can't really get down and penetrate it. So there's no economic response to fungicide after canopy closure.
Neil,
Yes.
we're getting a little bit of feedback happening. I know somebody had complained there, so it's just
Wonder what
just
that
had
is.
to mention that. Yeah,
Sorry about that.
no problem.
That's probably the sensitive microphone I have.
Probably, yeah,
I'm real sorry about that, folks.
no problem.
Know
It's
what to
not it's not too bad. Sometimes it comes, sometimes it doesn't. But
do. Okay.
Okay.
Root rots are pretty serious now. They've always been a bit of a problem in field peas. So we've got Fusarium, Pythium, Rhizoctonia, and Aphanomyces. Crop rotation is helpful, so stay away from pulses, pea and lentil. Most of the root rots affect both pea and lentil, so stay away from them for 3 to 4 years, away from susceptible hosts like pea and lentil, and especially in infested fields. But if you've got Aphanomyces, you want to stay away from pea and lentil for 6 years. And this is especially in heavy clay soils. Fungicide seed treatments only last 2 to 3 weeks against early season root rot pressure. And so in the first picture there, you see the red streak through the root. You cut the root. If you see a weak plant, you cut the root open with your jackknife and you see a red streak. That means there's fusarium root rot there. The next one picture is Phantomyces. So the caramelized roots are the ones that are affected with Phantomyces. Disease management. So want to look at varietal resistance when you're choosing your variety. Good crop rotation is important. Scout for disease, use those scorecards. Foliar fungicide application if necessary, and seed treatment for root rots. Pea leaf weevil. This is a problem in pea as well. We talked about this in Fababine, so I won't have to repeat it here, but seed treatment is more effective than foliar post-emergent insecticide. Now we'll look at some lentil production. I actually have a whole presentation on lentil, 45, 50 minutes of a presentation on lentils, so I'd be glad to give that to you in the future if you wish. Lentil market classes, there are several market classes. The main market classes are small red, and that's and the greens. So the small reds, it's the cotyledon. It's inside the seed that's red. The outside of the seed is more of a grayish color. The most popular variety is CDC Maxim. There are many lentil varieties now. CDC Impulse, CDC Proclaim, they all perform pretty well. It's a small seed, early maturing, 95 days. It's got a good disease package, and it's Clearfield, so it's group 2 herbicide tolerance. Now we're getting into group 2 resistant weeds. So people are putting down ethylfluralin edge in the fall, using some of the new group 14 and group 15s in the spring. So large green market class is the second most popular lentil in Alberta and on the Canadian prairies. These are large greens. They have a yellow cotyledon, yellow inside. They're a little later maturing, about 100, 105 days, so about the same as wheat and canola. We've got Clearfield varieties, and there's the breeders tell me the best one right now is CDC Green Star, and it significantly outperforms other large green varieties. It's got vigorous growth and a really good disease package in it, but it's not Clearfield, so you can't use a group 2 herbicide on it. Other market classes I'll just mention, French greens, yellow cotyledon, and Spanish browns. These are grown very little on the prairies, but there is potential niche markets, and some pulse growers do grow them, and the breeders keep breeding for them. Now, this is the lentil breeding for grower satisfaction. This is probably the most important slide in my presentation today. People sort of have a bad attitude towards lentil because of what they saw in the 90s and the 80s and the early 2000s. It was kind of a sloppy plant that kind of lodged a lot, and the seed would go right to the soil surface, and you couldn't pick it up very well. But plant breeders have done some amazing work to help with grower satisfaction with lentil production. So it's potting a lot higher. It's 3 inches from the soil surface. So with land rolling, you get significant reduction in harvest cutter bar challenges. The worst disease was Ascochyta disease, and now all the varieties are resistant to Ascochyta, and Anthracnose is still a bit of a problem. They're breeding for it, so we get intermediate resistance there, and it's a disease you still have to watch for. Clearfield has helped, making them group 2 herbicide resistant. So we can use Pursuit, Odyssey, Solo, Aries. They're higher yielding. They're higher yielding, and they have lodging resistance. And I haven't seen one of these lodge yet at all. So what they've done is they built in a larger stem base, and that helps prevent lodging. They're earlier maturing, and they are more determinate versus indeterminate. So you may recall the older varieties used to, if there was extra water or nitrogen in the soil, they would just kind of grow rank. They would keep growing vegetatively and not go to seed. And so they're breeding that out of it. So it's like other crops where no matter what, it'll go to seed. So, and I've seen these now in moisture areas, and it stays moist through to the end of July. And sure enough, these things go to seed, whereas those old ones just would have just kept on growing vegetatively. So there's a lot easier to grow than they used to be. Adaptation used to be in the dark brown soil zones. But now we can grow them into the black soil zone. Here are the soil zones in Alberta. Can you see the gray area just above the brown? That's where we are here in the Forestburg area. So we can actually grow lentil fairly easily now. But I would suggest to be careful on heavy clay soil if you're in a high rainfall area. A lot of lentils growing on heavy clay soil in Saskatchewan and Alberta in the drier soil zones. But look at the pictures on the right. You see how there's been flooding there. So lentil are very susceptible to waterlogging. So if you're going to grow them in the black, gray soil zones, you should grow them on lighter textured soil like sand or loam. There's waterlogging on the clay loam soils. Root rots, same as in peas. That's a challenge, and perennial weeds can be a bit of a challenge with lentil as well, because there's not a lot of herbicides to control them. So perennial weeds are generally controlled in other crops. So this is just a little bit on the yield and the price. The average yield is 1,500 pounds an acre on the Canadian prairies, so 25 bushels the acre. An experienced grower will get 1,800 to 2,200 pounds an acre, so that's 30 to 35 bushels the acre, if everything goes right with the weather, etc. The price, long-term average, is 24 cents a pound. The current price is 30 to 35 cents a pound, and the variable costs are $180 an acre. So if you take the average price times the average yield, you get $360, and variable cost at $180. You subtract that from $360 and you make $180 an acre. That's your contribution margin with revenue minus variable cost. Now, if you take the going price today, 30 cents, and you take 2,000 pounds, you get 600 minus 180 variable cost. You come out with a contribution margin of $420 an acre. And so you can see that the people that learn to grow this crop and then wait to grow it when the prices are high, they can really make a dent in their operating loan when they grow lentil, because you can make a lot of money off this crop. Early seeding is okay. It's tolerant to early spring frost. So it's just like pea, it's going to reemerge from the lower nodes. See on the right-hand side, that diagram, there's a node right at the soil surface, and there's a node just below between the seed, the cotyledon at the bottom that's growing from, and the soil surface. So it will come back. When you get a frost, it'll come back from one of those two. Land rolling, it's pretty much the same as pea, except you can go a touch later, 5 to 7 node stages. Ascochyta blight I talked about. It's used to be the worst disease. Now all the varieties are resistant. Anthracnose is still a bit of a problem, and they're breeding for more complete resistance. And you may have to apply a foliar fungicide, so you'd spray at the beginning of flowering or at the onset of the disease. And here's the scorecard. It's a different scorecard than the one for field pea. So if you do grow lentil and you need this, please let me know. It's the same idea. 50 is your risk value. Anything above 50, you spray. Anything below, you do not have to spray a fungicide. But there is sclerotinia with this crop as well. So these are the same comments as I had with field B with sclerotinia. Root rots, same thing with lentil as we had with bees. Disease management, same thing. Varietal resistance, try and select varieties that are resistant. Crop rotation scout. Use a scorecard to decide whether to apply a fungicide, and use a seed treatment for root rots, especially if you're on heavy clay. So harvest herbicides, we know there's a problem now with maximum residue limits. So this is a great website. You keep it clean. So before applying harvest herbicides, Reglone or glyphosate, whatever, contact your buyer or look at this Keep It Clean website. So, eat pulses produced on the Canadian prairies. Have you seen these in grocery stores? Souptacular. Actually made in St. Albert. Buy them at a store near you. You can support the prairie pulse growers if you do so. These are made from prairie pulses. I eat them all the time. They're great. They got a little package of seasoning in there. They're wonderful. So that's the show, folks. Sorry, my throat was a little bit sore here, so I had to drink a little bit of water. That's maybe where that little thrashing around with my microphone happened. So I apologize for that. Please call me, email me if you want. I'm available, and I'd be glad to help anyone out.